Assalamualaikum warahmatullahi wabarakatuh. Hello everybody. Welcome to our class, Praktikum Analysis and Design. In this chapter, we will study about ER diagram. Let's see the discussion about this chapter. Okay, in this chapter, you will learn about the main characteristic of entity relationship component, and then how relationship between entities are defined and refined, and how those relationships are incorporated into the database design process. How ERD components affect database design and implementation, and that real-world database design often requires the reconciliation of conflicting goals. So, in this subject, we will discuss about the ER modeling. The entity relationship model, ER model, forms the basis of an ER diagram. ERD represents conceptual database as viewed by end users. ERDs depict database main components like entities, attributes, and relationship. So, in this entity relationship model, we can learn about the component like entities, attribute, and relationship in the ER model. Entities. What is the entities? Refers to entity set and not to single entity occurrence. Corresponds to table and not to row in relational environment. In both chain and cross-foot models, entity is represented by a rectangle containing entity's name. Entity's name, a noun, is usually written in capital letters. So we have to approach, we can use chain or cross-foot models. The name of the entity is usually written with the capital letters. Attribute. Characteristic of entities. In chain models, attributes are represented by ovals and are connected to entity rectangle with a line. Each oval contains the name of attribute it represents. In cross-foot model, attributes are written in attribute box below entity rectangle. So, the difference between the chain models and the cross-foot model is about the notation. In chain model, we use ovals, and then the cross-foot model, we use attribute box below entity rectangle. In this image, we can see the difference between chain model and the cross-foot model. In chain model, the entities represented by the rectangle, and then the attribute represented by the oval image. In cross-foot model, we have rectangle, but the attribute is below the rectangle. domains. Attributes have domain. Domain is attribute set of possible values. Attributes may share a domain. Identifier or primary keys underlined in the ERD. Key attributes are also underlined in frequently used table structure shorthand. Composite primary keys. Primary keys ideally composed of only single attribute. Primary key composed of more than one attribute. It can be possible to use a composite key. So the difference between the primary key and the composite primary key is about the attribute that we use. In the primary key, the attribute only single. But if we use composite key, it's more of than one attribute. Composite and simple attribute. Composite attribute can be subdivided. Simple attribute cannot be subdivided because we know that simple is cannot divided. Single value attribute can have only a single value, but multi-value attribute can have many value. So this is the difference between the composite and simple attribute. The composite can be subdivided, but the simple attribute cannot be subdivided. Single value is only have a single value, but multi-attribute value can have many value. This is describe about multi-value attribute in an entity. And we can see that the chain model and cross-foot model, multi-value attribute can represent by this image. We use double line to show about the multi-value attribute. In the chain model, we see that the car entities have attribute: car vehicle information number, mode code, car year, and the car color. In this car color is multi-value attribute. And we see that the cross-foot model we can represent like this. So we can see that car vehicle information number is the primary key, and then the others is our attribute: mode code, car year, and car color. But in the cross-foot model, we cannot see what is the multi-value attribute. But in the chain model, we can see that car color represented by the double line. How about resolving multi-value attribute problems? Although conceptual model can handle many-to-many relationship and multi-value attributes, you should not implement them in relational DBMS, database management system. within the original entity, create several new attributes, one for each of the original multi-valued attributes component, can lead to major structural problem in table. Create new entity composed of original multi-value attributes component. This is resolving multi-value attribute problems. In this slide, describe the splitting the multi-value attribute into new attribute. As we see before, that the car have many attributes, and the color is multi-value attribute. In the chain model, we can see that car vehicle number is primary key, mode code, car year, and then we split the color. We split the multi-value attribute about the color, become car top color, car trim color, and car body color. So this is the splitting of the car color. Car color, we can divide it into top, into trim, and then into body color. In cross-foot model, we can see that the car color divided into top color, trim color, and body color. This is what we call resolving multi-value attribute problem. In this slide, we see that component of the multi-valued attribute have two rows. I mean two column, the section column and the color column. The section have top, body, trim, and interior. Top color is white, body color is blue, trim color is gold, and the interior is blue. So the section may have a different color. That's we call multi-value attribute. A new entity set composes a multi-value attributes component. In this slide, describe car entities car entity and then car color. The car have relationship has with one to many, to car color entity. In the car entity, we have three fields: car vehicle information number, mode code, and car year. In car color, we have car vehicle information number, call section, and call color. In the car entities, we only have car vehicle number as primary key, and the car color, in the car color entity, we have car vehicle number as primary key and foreign key in car color, and primary key in the car color entities with column section. derived attribute. Attribute whose value may be calculated derived from other attributes. Need not be physically stored within database. Can be derived by using an algorithm. So we can use derived attribute by using an algorithm. This is derived attribute. In this slide, we can see that employee age as derived attribute. The entities of employee have employee number, employee last name, employee first name, employee initial, employee DOB, and then employee age. In the employee age, we can see that it cannot derive it. It can derive it by the other entity. So it's automatically derived by employee born. So employee age, we can derive it by the date and the year of the employee born. This is the advantage and disadvantage of storing derived attribute. That we can see save CPU processing cycle. If data value is readily available, can be used to keep track of historical data. This is the advantage of the stores. And then cell storage space. Computation always yields current value. Is not to store, but we have the disadvantage of the storing derived attribute. This advantage requires constant maintenance to ensure derived value is current, especially if any value used in the calculation change. So if the calculation is changed, we have to backward about and to make sure that there is any change. And then uses CPU processing cycles as coding complexity to queries is not to stores. Relationship association between entities. Participants are entities that participate in a relationship. Relationship between entities always operated in both directions. Relation can be classified as one-to-many. Relationship classification is difficult to establish if know only one side of the relationship. Connectivity and cardinality. We can describe connectivity is the relationship classification. The connectivity used to describe the relationship classification. But the cardinality expresses minimum and maximum number of entity occurrence associated with one occurrence of related entity, established by very concise statement known as business rules. In this slide, show the connectivity and the cardinality. There's two entities, professor and the class. This is show the connectivity, and this is show the cardinality. Entitas professor to entitas class, connectivity by teachers, and then the cardinality, professor 1-1, and the class in 1-4. Existence dependence. Existence dependence exists in database only when it is associated with another related entity occurrence. Existence independence. Entity can exist apart from one or more related entities. Sometimes refers to such an entity as strong or regular entity. This is the difference between the dependence and the independence. The dependence is associated with another related entity occurrence, but the independence is apart from one or more related entities. Sometimes refer to such an entity as strong or regular entities. Relationship strengths. We have two: weak or non-identifying relationship and strong identifying relationship. The weak relationship exists if primary key of related entity doesn't contain primary key. We have underlined that the weak relationship doesn't have primary key component or parent entities. But the strong identifying relationship exists when primary key of related entity contains primary key component of parent entity. So we can call this strong relationship because the entities have primary key in parent entities. In this slide, we can see a weak relationship between course and class. Why this relationship we can call weak entities between courses and class? As we see, the entities course have many attributes. In course, have primary key attributes CRS code as the primary key, and have another field like department code, CRS description, CRS credit, and have a relationship to entity class, one-to-many course generated class. In the entity class, don't have primary key. It's generated from the CRS code in courses. So we can see that the entity of class have another field like CRS code, class section, class time, room code, proof number. The class cannot exist when the course is not exist. But if the course is exists, the class will be generated as the entities. In this slide, we can see that the student class have CRS code ACCT 211, and it can generate two CRS code ACCT 211. So the class will not exist if the table student not exist. But if the table student is exist, it could be generate class entity. Strong identifying relationship. A strong identifying relationship between courses and class. In this slide, we can see that the course is a strong relationship because the course can be exist even the class is not exist. The courses can be generated in class, but if the course doesn't exist and then the table class is not exist. Weak entities. Weak entities meet two conditions. Exist independent, cannot exist without entity with which it has a relationship, has primary key that is partially or totally derived from parent entity in relationship. Database designer usually determines whether an entity can be described as weak based on business rules. Okay, this is described about weak entities. We can see in this chain model and then cross-foot model, the weak entities can be described like this. We can use double rectangular to show the weak entities in ERD. So if we have this notation, we can know that the dependent entities is a weak entities, but the employee is a strong entity. So In cross-foot model, we cannot see directly, but we can see to analyze it. This is the difference between the chain model and the cross-foot models to describe about the weak entities. This is a weak entity in a strong relationship. As we know, the course is strong entities, and then the class entities is a weak relationship. We can see that the employee number is can generate in the class number. Relationship participation. Relationship participation divided into optional participation and then mandatory participation. An optional class entity in the relationship professor teaches class. As we can see, the professor is mandatory and then the class is participation. This is in this slide, we can see that professor entities and the class entities have relationship, and we can see the relationship is teaches professor teaches classes. So in the professor, the cardinality 1 to 1 and the class is 0 to 3. Class is optional to course. In this slide, we can see that the entity course entities, and the class entities have relationship generate, where course in 1 to 1 and then the class is 0 to many. Course and class in mandatory relationship. So this is described, then course and class is mandatory. The cardinality of course is 1 to 1 and the cardinality of class is 1 to many. This is the cross-foot symbols. Cross-foot symbol have 4 notation. This is the first notation. Shows the cardinality 0 to many, or we can say many side is optional. And the second is 1 to many. We can see that many side is mandatory. And the third is 1 to 1. One side is mandatory. And then the last, the cardinality is 0 to 1. One side is optional. So if we see the notation, we can know the use of this notation or these symbols. Relationship degrees. Indicated number of entities or participants associated with a relationship. The unary relationship association is maintained within single entities. If we find unary relationship, we can see or we can say association is maintained with single entities. How about binary relationship? In binary relationship, there's two entities are associated. And the ternary relationship, we can see three entities are associated. Relationship degree. In this slide, we can see three types of relationship degree. This is we can call unary relationship because only entities relation. And then this is the binary because there's two entities relationship. And then this is ternary relationship because there are three entities that relationship each other. This is the relationship degree. We can see the drug entities and the patient entities and the doctor entities and the prescription entities. In this slide is the implementation of ternary relationship. As we can see in this slide, that the prescription relation with the doc's ID, the doctor ID, and then the patient number, and then the drug number, the drug entities. So we can say this is the implementation of ternary relationship because prescription show the relation between the doctor and then the drug and then the patient. Recursive relationship. Relationship can exist between occurrence of the same entity set naturally found within unary relationship. In this slide shows about the recursive relationship. In unary, the relationship is included in the entities. So we can call this is recursive relationship. As we can see like this, the entities course have relation requires and is prerequisite to course. So this is recursive relationship. This is the example of the recursive relationship. In this slide, we can see the one-to-one recursive relationship. Employee is married to employee. So we can see the Ramirez last name and first name James is married by Luis. So Ramirez married to Luis. We can see the employee number and employee spouse. And we can see 347 is employee last name Ramirez and employee first name Luis. This is the recursive relationship. Employee is married to employee. Ramirez married to Luis. In the same table, the employee table. Another unary relationship part contains part. Part contain part. We can see in this part table, there is relationship part contains part. We can see the rotor assembly is part of part A8216, and then AB121, A129, X10, X34AW. So this is the recursive relationship. Part contains part. Implementation of the many-to-many recursive part contain part relationship. Component entity and the part entity has recursive relationship many-to-many. As we can see, the component entities have part code AA216, and the table part has AA216. Implementation of the many-to-many course requires course recursive relationship. In this slide, we can see that the course entities have many-to-many recursive relationship. Implementation of the one-to-many employee manage employee recursive relationship. In this slide, we can see that the employee code 121 as employee manager for I mean 102 is employee manager for employee code 101, 103, 104, 105, and 106. This is the implementation of the one-to-many employee manage employee recursive relationship. Composite entities, also known as bridge entities, compose of primary keys of each of the entities to be connected. May also contain additional attributes that play no role in connective process. This is the composite entities, converting the many-to-many relationship into two one-to-many relationship. As we can see, there's three entities or there's three tables: the student table, the enrolled student, and the class table. In the class, we can see that the enrolled student is a relation with the student number and the enroll grade. The enroll generate class and then relation with the student table. As we can see, the class code enroll code generate to class table, and then the student number generated by the enroll table. This is the converting from the many-to-many relationship into two one-to-many relationship. Composite entities, the many-to-many relationship between student and class. So in this slide, we can see two entities, table student and table class, and have relation and roles. A composite entity in an ER diagram. The student table has primary key, student number, and relation is written in enroll, and relation table enroll to table class is found in class. So we can see the enroll table has primary key, foreign key 1, and primary key and foreign key 2. Foreign key 1 from student entities, and then the primary key 2 from student number. Primary key as foreign key 1 from class code. Developing an ER diagram. Database design is iterative rather than linear or sequential process. Iterative process based on repetition of process and procedures. So we can develop ER diagram based on this information. Building an ERD usually involves the following activities. Create detailed narrative of organization description of operations. Identify business rules based on description of operation. Identify main entities and relationship from business rules. Develop initial ER diagram. Identify attributes and primary keys that adequately describe entities. Revise and review ER diagram. Tiny college. Tiny college is divided into several schools. Each school is composed of several departments. Each department may offer courses. Each department may have many professors assigned to it. Each professor may teach up to 4 classes. Each class is section of courses. Students may enroll in several classes, but she or he takes each class only once during any given enrollment period. Developing an ER diagram. Tiny college. Each department has several students. Each student has only a single major and is associated with a single department. Each student has an advisor in his or her department. Each advisor counsels several students. The relationship between class is taught in a room and the room in the building. We can developing an ER diagram based of the description of the business process like this image. The first tiny college ERD segment. There are 3 tables: professor table, school table, and the department. The professor has relationship is dean of school. And then the school has relationship to department as operate school operate the department. The professor entity have foreign key, prof number, and have several attributes. And the primary key in the professor table become foreign key in school table. And the department has department code as primary key and school code as the foreign key. So from the describe of the business process, we can draw or describe GER diagram. Second tiny college ERD segment. So in this slide, we can see the department table and the course table. Department have primary key depth code and over relationship, and the primary key of department table became foreign key in courses. The third tiny college ER diagram segment. We can see the course table and the class table. The course have primary key CRS code and the class have primary key class code. CRS code become foreign key in the class table. The fourth tiny college ERD segment. So we can see that the professor table and the department has two relationship employees in chairs with the primary key fob number become foreign key in department and department code become foreign key in professor table. The fifth tiny college ER diagram. In this ER diagram, we can see two entity, the professor entity and the class entity. Professor entity have primary key prof number become foreign key in class table and have relation from professor table to class table as teach. The sixth tiny college ERD segment. In this slide, we can see three tables, student table, enroll table, and the class table. Student table has student number as primary key. Enroll table has primary key from another table, student number, and the primary key from foreign key class code. So the foreign key from another table became foreign key in this enroll table. And the relationship between the student to enroll is written in, and the relation between the enroll to class is found in. The 7 tiny college ERD segment. The department table and the student table have a relationship as department code as primary key and become a foreign key in the student table. The 8 tiny college ERD segment. We have 2 tables, professor table and student table, where the table of professor has proof number as primary key and become foreign key in student table. The 9 tiny college ERD diagram segment has many entity, building entity, room entity, and class entity. Building has block code, building code as primary key. Room has room code as primary key, and class has class code as primary key. Building to room has relationship contains. Room to class has relationship issues for. And we can see that building code became foreign key in room, and room code become foreign key in class. Component of the entity relationship model. So we can see this is the component of the ER model from entity school, department, course, professor, student, building, and room. And this is the relationship, this is the connectivity, and this is the entity. Became a component of the ER model we represent in table. It can make easily to search or to analyze. This is the completed tiny college ERD. So we can divide it into several describe to make the analysis system more easily. But this is the complete of tiny college ERD. Database design challenges conflicting goals. Database design must conform to design standards. High processing speeds are often a top priority in database design. requests for timely information might be focus of database design. Various implementation of the one-to-one recursive relationship. In this slide, we can see the database design challenge about the conflicting goals. First implementation, we can see the employee has employee number, employee name, employee first name, and employee's post. And then we normalize into second implementation. So we have two entity, employee and merit. And then third implementation became three table or three entities, marriage, merit part, and employee. This is the implementation, the relational diagram for the third implementation. Marriage to merit part is one to many, and the merit part is one to employee table. Summary, ER model uses ERD to represent conceptual database as viewed by end user. ER's model's main components, entities, relationship, and attribute, include connectivity and cardinality notation. Connectivity and cardinalities are based on business rules. In ER's model, many-to-many relationship is valid at conceptual level. ERDs might be based on many different ER's models. Database designers are often forced to make design compromise. Thank you. And this is all of the learning in this class. See you.
Demikian materi pembelajaran pada hari ini. Mudah-mudahan apa yang disampaikan bisa meningkatkan pemahaman, pengetahuan, dan kompetensi kalian di dalam melakukan kegiatan analisis dan perancangan sistem informasi. Baik, saya akhiri. Wassalamualaikum warahmatullahi wabarakatuh.